Good morning, everybody. We are getting started since we're a few minutes late. So this presentation will be co-presented by myself and Eric. So I'll start, then he'll take over, and then I'll finish off. And I'll tell you up front that there's more slides than we're covering, but we decided to leave the slides. So because you guys are going to get access to the slides, you will have additional information and more food for thoughts if you want to follow up with us. My name is Carini. I'm a data scientist at OmH and UCSF. And we're presenting in this project called OmH-on-FHIR. This is our group. As always, the people that present are a subset of everybody who's contributed to this project. The PI is Ida Sim at UCSF, and there's myself and Eric. Then we have two people at Georgia Tech, and then another person from OmH. Oops, I'm going too fast. So I will introduce OmH and the use case that's been driving this project, and then Eric will take over and describes the FHIR Implementation Guide, and then we're going to hopefully be able to do a little demo of the project. Introducing OmH is a nonprofit that was started at the end of 2011, has been originally funded by the Robert Wood Johnson Foundation and then the federal government through 3 different grants. And right now, the work that you're going to see mostly is being funded by a grant that is focused on standardization. So this is the use case that we use to drive our project. Our PI is a physician, so this reflects an encounter with one of our patients as a person with moderate cardiovascular risk. The physician advises to start physical activity, starting with 4,000 steps a day. They see each other 3 months later. The person has a physical activity device, and then 3 months later, when they see each other, they want to review the data. Now, the physician is not interested in seeing day-by-day step count, but just mostly the overall progress this person has done in increasing the activity. And the data resides in the person's mobile device, does not necessarily need to go into the EHR. That depends on the hospital or the physician. But what the physician wants is to see the data from the mobile device within the context of the person's other medical history and prescription, so within the context of the EHR. So what do we do at OmH? We have devised schemas, JSON schemas for mobile data. And this is an example of the current version. This is 2 instances of the current version of the step count. The schemas are very simple. In this case, each instance has a header, which is not shown here. I'm just showing the data point. And I'm showing examples of 2 different things. One is just an instance of a step count within a specific time interval. But then the schema allows to model also descriptive statistic. In this case, it would be the value would be the average daily step count within the time frame described by the time interval. So in short, what is the use case and what is driving our work is to make data aggregation from mobile data accurate so that it can be used within the context of the overall healthcare for the person. So this will allow to facilitate the development of digital biomarkers. Those are biomarkers that use the wide and increased availability of data captured where the person lives and works versus just when the person sees the physician in the office rarely. We have applied some design principles. So as I explained, each data point, of which you saw an example, has a header and a body. You will see some of this again as Eric does his presentation, and each schema is annotated to a standard vocabulary. We also developed a tool called Shimmer, and Shimmer is a set of shims, and each shim takes data from some common provider, for example, FitBit or Google Fit, and transforms the data into OmH compliant format, meaning in the format that complies with the schemas that we have developed. And the initial driving was cardiovascular health, so heart rate, respiration rate, blood pressure, and physical activity. But then we've expanded, and right now, most of our work is done within an IEEE working group. We've been working for about 16 months now. So our goal is to become IEEE certified. And the certification right now focuses first in designing principles, but we're actually working also on sleep-related schemas and physical activity schemas. And we have a very large subgroup, it's a very large working group, but we're always welcoming new members if people are interested in joining. So the two links are our website, where there's a lot of information, including all the schema library, and then the IEEE site, where people can join the listserv. These are slides, as I mentioned, more for you to think later, but what we put here is like that OmH and FHIR are actually co-evolved, and OmH is very focused on mobile health. So data that are very personal, a lot of data, and atomic, but and our needs are focused on the mobile health. FHIR is very much focused on the healthcare and EHR. And here there is another slide that compares, the difference between mobile health and EHR data. Mobile health is very personal. It's a lot of data. It's captured 24/7. It's very noisy. There's many companies contributed to the space. EHR is episodic care encounters. It's very stable. It's very structured, but it's a lot more complex. And here now is Eric to continue.
So what I'm going to talk about is how we've tried to integrate the OmH work, the schemas, and try to map to FHIR. So we actually created an implementation guide, which is still in draft, and we've gone through a couple iterations here. And we're going to talk about taking the OmH schemas and converting them to FHIR to help integrate some of the mobile health data through OmH into the FHIR ecosystem. Okay, so here's just a splash page at the front page of the OmH to FHIR Implementation Guide. It talks about a couple of things. It talks about our use case, which Simon went over, a smart app workflow. We actually have a little demo. We're going to show that later on. And then we talk about the OmH to FHIR mapping. And I'm going to talk a little bit about that right now, where we try to take the schemas and map them to FHIR. So as an overview, there's about, how many data point schemas do we have? About 20, 30 right now?
A bit more, but
okay,
yeah. There's a lot of supportive also schemas that you show. Yeah.
So just as an overview of mapping, the idea of mapping is to take an instance from OmH data point and map it to a FHIR instance. And in general, as Simona mentioned, on the OmH side, we have these JSON schemas, and they're basically two objects. You have a header object and a body object. They're relatively flat. They're relatively simple, which is kind of nice in the mapping from trying to map them. So we have a relatively flat, non-repeating schema, and then there's a set of schemas a subset of schemas that represent basically value sets. They're basically enumerations. There's a set of schemas that represent basically in FHIR data types. So we have a third set of schemas, which I refer to as data points, or data point schemas. They're actually the measurements. They're actually measurements like a step count, like a heart rate, sleep duration, those kind of things. And that's really the focus of this, is to take a measurement that was captured and is represented in OmH as like sleep duration and convert that to a FHIR representation. And so in FHIR, we're taking most of these schemas are basically measurements. So they're basically going to be mapped directly over to an observation. In FHIR itself, we have a lot of nested elements. We have repeats everywhere. And just the converse is true. Many of the FHIR value sets kind of roughly equate to an OmH schema, and the FHIR data types roughly equate to many of the OmH schemas. So, and just if you look at the schemas in here, a lot of the schemas will represent, well, in a schema, like a data point schema, it will actually point or reference itself to another OmH schema, which is essentially going to be a data type or a value set. Okay, so my approach to the mapping was to create a bunch of value sets out of the OmH schemas that represent value sets, because that becomes rather static and it's kind of used to reference and to do some mapping. So I created this master list of OmH values, and I did a concept mapping over to the FHIR values. And then a map as a separate set, a set of tables where I have FHIR data types mapped to the OmH schemas where the schemas are representing data type. And where we have the OmH schemas that are data types, like a step count, then I created a table. In other words, I created a table because in observation I need a code, and in the observation code, and basically a category. So I was able to take each schema and say that corresponds to this observation with this code in this category. And so I have basically a table that each schema gets a code, a LOINC code, in some cases a SNOMED code, and each schema gets a categorization. So I've just created a bunch of tables to start out with. So it gives me a starting point. Okay, so I struggled a little bit making this structure mapping available and accessible. I've gone through a couple iterations, and so I've looked at the FHIR mapping language. It's actually going to be the most flexible and the most useful, but it's really the hardest to understand when you just look at it. And I try to use templates and text and stuff. I'm using spreadsheets. There's actually another problem. There's another big mapping project going on in HL7, the version 2 to FHIR mapping project, and they presented their work using spreadsheets, and they had a pretty convincing argument. I know we're not all in agreement about that, but it's a good way to review it. It's accessible, so we can look at it. So I'm going to use, I've stolen their templates for Excel's templates, so I can show you what the mappings look like and how they're being presented. And just as an aside, having a flat, non-repeating structure makes it really easy, I think, to represent them as tables. If it was much more complicated, it probably wouldn't be as successful. But I'm going to show a couple schemas here. And so I'm going to do a little flip over here to command. I'm going to open this up real quick. I didn't get a chance to set this up, so I apologize for the delay here. So I'm going to start out and say we have I'm not going to go through the whole thing here. I just want to point out what we got here. Let's see what it looks like on the screen here. Okay, so this is my left. On the left side we have, and I label it as the OmH side. Sure. And on the right side, we have how it maps over to the observation. Okay. There's a lot of data in here. I'm just going to go through a few data elements to kind of point it out, and I'll go over generally. There's a lot of data in here. It's really hard to look at this and capture it all in, but it'll be in the notes. The link to this is open. And if it isn't open, let me know and I'll make sure it's shareable. So I'm going to have to get my glasses on so I can see. So if you look at the left side, we really have, these are in the OmH schema, these are the elements that are in, on the column B, those are all the elements that are in the header element. And then it maps across over to the SGU3 observation. I think I have to go in here and move this across a little bit. There we go. Okay. So if you look at the first line, that's just gives you the overarching JSON schema link right up there. It tells you, gives you descriptions. And so we have the first element, header ID. And we go across from the green side to the yellow side. We see that maps over to the observation identifier. And so we come across here, and then there is a data type mapping over here, and that just basically tells you there's the cardinality on this side is 1 to 1, cardinality on the FHIR side is 1 to many, and we actually have a sub-mapping to the data element itself in here. And if I click on that, we should be able to see that. So this is a basic way I'm trying to represent all these mappings so you can look at them. Most of us are, I think everybody here is familiar with spreadsheets and how to navigate a spreadsheet. So again, we're just going to map across. So we have the OmH information on the other side. We have the name of the element, the header ID. It maps across over to the identifier value on the other side. And then the system becomes a fixed value where we've assigned a fixed value for the system for that identifier. So that's kind of the pattern I have. We have the root level mapping, and then you click on to get to the more detailed, usually data type mappings in this schema, in this display of how I represent the mappings. So if I go back, see here, there's a couple other ones I want to point out. So in some cases there are known mappings. We have some infrastructural elements over here, the header schema ID namespace. I didn't map those. That may change, but right now I don't see where that would go into our mapping. There's another thing. We have a couple places where I mentioned before, we have these tables where we mapped all the ID schema names to table names, and that's where we map from the ID schema name maps over to the category and code. So we start building out the category and code for the observation. And this is all header information, and then we're going to skip over to the body part in the next slide. And I'll just point out that we have these tables, and that kind of points to a category mapping. And in the category mapping, we have so we map the category, and by doing that, we have this this data point mapping table. And so I'm just using a little notation here, and I have to put some annotation up top there how that reads. But basically, we have a mapping table, and we'll have a couple indices that map to the row and a column in that situation here. So basically, we have this mapping table, and I'll show it to you in a second. And basically, the row is the same as the schema ID name, and then you go over to the column to find the actual observation code that you're going to use. And let me just point that out here. This is extremely small, but if we go over here, we can see, for example, we have, for example, heart rate over here. It maps over to the code vital signs for category. And then we have the code here. There's actually a link code. So the heart rate schema ID maps to two different elements. So we have the header mappings, and then we go to heart rate. I'm going to skip over step count. That's a bit of an outlier in the patterns, but the big point I want to make is we start mapping out heart rate as kind of our paradigm mapping, and then everything else has the same pattern. And if we look at, I have heart rate, body temperature, blood glucose, and there's like 20 more schemas, but they all kind of use the same mappings in here. So for body temperature, all these things are repeated, and you just have a new element in it we have to do an individual mapping for. Same with blood glucose. So the pattern starts getting, you start mapping 3 or 4 things, and you start having many mappings done. You just have to follow the same pattern you see in the heart rate. So, so if we look at this, here's a body schema. And I just listed out, I just did a dot notation to spread out the schema elements. We have date time up top. Okay, so first of all, I list the schema up top. We have the body dot heart rate is the value. So, and that actually will map over to the heart rate value quantity. And we have a data type mapping for the quantity. So let's take a look at how we map the actual value of a heart rate from an OmH schema, which has a value to the value quantity. So we have the code, we have the category, and now we're going to look at the quantity of this particular mapping. And so we have in the OmH side, we have this idea of a quantity schema. It's not called quantity. It's called unit. I think unit. It's called value. Unit value. And so in that schema, we have two elements: body, unit. We have unit and value. And so they map directly over to our FHIR quantity data type. And so the top line is the value that maps to value quantity value, and then the unit maps over to our value quantity unit in FHIR. And then I've done a mapping where I've taken that unit and I've UCOMized it. So I have a UCOM code in a mapping table where I've taken all those values, all those quantity values, and mapped them over to UCOM values. So we have 4 elements on the FHIR side that are mapped to the 2 elements on the OmH side. So basically, here we are getting a code, a category, and a quantity, which is kind of the meat and potatoes of observation. There's also a subject in here, and the method, and there's some other little tidbits in there that are being exposed by the step count. Exposed by the OmH schemas. And let me point out a couple of them. We have a modality in our headers that tells you whether this is self-reported, if it's actually being entered directly into the device, or if it's being sensed by the device. And so that I actually took and made an extension off of device to tell you that information. So that's one thing that's unique in OmH that I have represented in the observation as an extension. And if I look here, I don't know if there's any other extensions in this particular example. Descriptive. The other extension that I did resort to when mapping over to FHIR was something that's actually now a standard extension in R4, which is specimen code. In the FHIR observation, our specimen element actually is a reference to a resource. And so in OmH, they're using code, so we have an extension that we're using to represent specimen codes. So I have the header is mapped, heart rate's mapped, and then we go to another vital sign, such as body temperature, which actually has a body location element, but everything else maps over to heart rate. So if we have that first set of mappings done with heart rate, then we just have to add in what's different here, and that's just basically looking at the measurement location, the body site. So that's to map over to body site. And similarly for blood glucose, which is lab measurement, everything really maps the same pattern as heart rate, except we have the specimen code. I mentioned that before. We have a specimen code in there. So that's enough of spreadsheets for now, but you can take a look at that. So we've really tried to make this accessible and easy to look at, so you can actually say, this, how do I, when I'm coding this, how do I associate this particular element with the FHIR element? So it gives you kind of a guideline in that matter, and that's really what my goal was. So I've actually done this for using a little Python example, and since I didn't have time, I was going to actually show that to you, but I'm afraid I'm going to have to just show you a static view of that. I have, here's a bunch of map schemas. This is what I've mapped so far. And oops, let's try to make that full screen. Okay, so here's a list of data point schemas that are currently available in OmH. And you can see there's all these map over to observation. There's also additional schemas, a few gaps. There's additional schemas in OmH that are designed for medication, and they would map to one of the pharmacy resources. I haven't looked at those in great detail. So I do have an OmH to FHIR mapping demo. It's on a Python and Jupyter binary. If I try to load this up, we'll be sitting around looking at a spinning wheel for 5 minutes. So let me just try to go to directly to the repo and give you a static view and just show you what that does, and just to show it can be done here and how it would play out here. Okay, so this should give us a static view of this. Okay. Unfortunately, I can't run it. I can get rid of all this noise and code, but basically, it runs a bunch of these things. And basically, if you paste in an example, it will basically. It's a bunch of documentation. Now basically, this isn't going to work because I don't have the active ones. But basically, what you can click on this on the launch, and you'll see a place to copy and paste in examples. I'll give you a link to where some examples are, and you'll just find the nice, pretty observation come out the bottom end. So, and this is all in Python code. It's out there and freely available, and it validates. So here's basically what it would look like if you took. And this is step count. What is this? This is body temperature. So basically, here's what it looks like when you're done. You have I put a meta profile in it, but you have a body site with a coding. But this up top line is the body site coding, which is the mouth, and then we come down and we have the category and coding, which come from the schema name. In this particular case, there was a descriptive statistic called maximum, so we actually added a second coding to there. We have the device mode, which I talked about a little bit, and then we have the value somewhere in here too. The dates are all converted over, and we have where's our value?
Down there.
There you go. Okay, a value quantity. So, but yeah, so if you get the slides, you click on that little binder file. It actually will circle around a little bit, be a little patient, it'll show up and you'll be able to play with that, and it shows you how it can be done. So yeah, so I didn't want to take up all your time watching a little spinning wheel, so we're going to jump back into the presentation here. Okay, so we started this project with a goal to have a little demonstration project where we would take and describe the workflow that was described earlier, where we have a practitioner that wants to look at one of their patients' FitBit data or Google Fit data, and so we created a little demonstration app that actually shows this. So basically, the basic workflow is you have retrieving OmH data either in a native OmH format or retrieving it as a FHIR observation, which requires the mapping. That's why I went over that. So you have an EHR, has some OmH to FHIR server out there, and there's some patient mobile device out there, and so that OmH to FHIR server is grabbing that patient data from their little wristband, and then the EHR is able to go and look at that through a FHIR app and allow it to be exposed to the practitioner, or even the patient could look at it that way too. So we ran this through, and it's described in the implementation guide. We actually go into this in a little depth here. But here's a whole, it's kind of the OmH to FHIR high-level design. We have the EHR on the left side here. We have the device over there. You have like Google Fit, Fitbit, others. That list keeps changing. It shrinks as we move on in life, right? It's shrunk quite a bit, hasn't it? The last
They move on in life, I guess. Yeah, the devices. Yeah.
So in the middle here is our OmH to FHIR server. We mentioned a FHIR API, which can take all these different formats and kind of mush it into the OmH format. And then we have this OmH-on-FHIR database, and we have on this end we have a SMART-on-FHIR app, which allows you to access the data. And we do some mapping in the middle there too. And then here's our basic workflow that we wanted to go through real quickly. So we have the the client, the smart client, and we have the we call it the R24 server. There's no secret there. It's just because I was a grant, R24. So we have this FHIR endpoint, and so we start with the Smart app, which authenticates, and then we request the step count for the patient. That receives the request. It grabs the step count data from wherever that step count data is being stored. Usually for a device, they have their own source of where it's on your wristband, and then you can actually sign up to have it stored someplace else. And so it's retrieved from that. You get permissions, and you retrieve that data, and then it's returned to the server. It does the conversion to the Open mHealth schema, and then it'll do a series of transforms to create either a binary file, a FHIR binary, or it does the transforms and creates the observations for that file. So when you call for that, you actually get a document reference which can point to the binary file or directly returns the observations. Okay, so we have a demo of this.
Okay. So I may need some help to go to the place and what we do. Can you launch the
I think I can.
For me while okay. So now that you've heard a lot of all the technical stuff that is behind, and it's at the bottom there. Okay, just click on that and then I should be able to. We'll go back a little bit to the use case. So again, the physician has recommended that the person increases his or her activity. And the physician is going to see the person 3 months later. The physician doesn't want to know every day how many steps the person does. It's more sort of like after 3 months, let's look at the situation, okay? And the other thing the physician doesn't want to do, the physician doesn't want to look at the person's device, in part because each one of us has a different device, and the physician has a workflow, and the physician's workflow is based on the EHR, because when the person arrives, they open their record, and so for the physician, it is more important to view this additional information that comes from the patient within the context of the EHR, without even, in this case, having to worry that the data feeds into the EHR, because the data remains outside. It's just the visualization happened within the EHR. The one thing that I should go back. So how does it work at the beginning? So in the first visit, the physician says, well, why don't you do this, and then in 3 months, we'll look at this. So the person has his or her own favorite device, and they only need to make a connection, of course, between their device and this, and I'll show you once, and then again, the physician doesn't need to have their password, and likewise, the Google Fit or Fitbit, they don't need to know the patient record, which would be not a good idea. So this link happens in the background without exchange of PHI information. So thank you. Well, this kind of skipped because I think that's the patient that happened yesterday. So maybe
it'll work.
Okay.
It'll work.
Okay. So it kind of skipped the authentication, and I can go back and show it to you later. But so the idea is that Yeah, the whole December. Thank you so much. So the physician clicked on a patient. There is the authentication. In this case, it was through Google Fit. And now we're looking at some data. So what are we seeing here? So this is, again, this is a smart app. So it's in the context. I don't have the rest of the EHR, but you can imagine it's a window overlapping on the EHR. So the physician still has all the information about the patient, what medications they're in, whether they had an event before or not. On top, they can visualize the data. Now, this is it's a month worth of data, and again, the visualization is provided by OmH. This is OmH data, but you can imagine any developer can be fancier than this. But the idea is that maybe the physician is probably not very interested in seeing every single day how many steps the person did, but to see a trend. And maybe this is kind of random, but see that maybe they're increasing or maybe they are decreasing, which would be a reason for worry. Maybe the person started walking more, and then at some point he started walking less. Maybe there's something else going on. So they can see this information, and they can expand it. They can drill down, as Eric showed. So if you click on a dot, you can see what the date was and how many steps there. And again, you can also imagine this. You can have more than one visualization. You can have, blood pressure correlated to or the maximum blood pressure, any other things. You can see that expanding. This is just, and then here for the this is also open, public. You will have links and you can check that. But the idea is you can see the actual FHIR observations as well as you can see the original OmH data. So now we're looking at FHIR observation, whereas the native OmH data is provided as document. And again,
I'll just go down and show you what that would look like. Yeah.
You have when you get the slides, you will have also screenshots that will guide you to because I did a live demo here. So
yeah, there we go.
Yeah. So if you look at that document reference and then you look at it in a text processor, that's what it looks like. And thank you, Eric, for showing that it has a reference to the binary that the
in the FHIR
source data. Yeah. Any questions on? We're
at time.
Almost to the end. I wanted to get to the last slide so that we have.
Yeah, let's get to the last slide. Okay.
Okay. See if we go back, and now we have time for some questions. So we did everything here. So this is basically the screenshots of what I showed you.
The very last slide?
Yeah. So, and this is us. Now, if do we have a time to see if I can do a login, like a connection? One of the patients can we go back to the?
We are 2 minutes over time.
We're 2 minutes over.
Oh really? Oh, okay. Ah, thank you. Thanks. Okay.